In this video, we will look at the addition rules for probability. This is the only video for this lesson. Two events are mutually exclusive or disjoint events if they cannot occur at the same time. For example, we can consider the colors of my Sharpies. I have many colors, but if I choose one at random, it can't be both green and purple, just one or the other. So here we'll determine whether two events are mutually exclusive. Can we select a female student? Is selecting a female student or a student who is a freshman mutually exclusive? No, these are not mutually exclusive events. There are many female freshmen. Randomly selecting a person with type A blood and randomly selecting a person with type O blood, however, are mutually exclusive events. A person has only one blood type. Rolling a die and getting an odd number, or rolling a die and getting a number less than 3. These are not mutually exclusive events because 1 is an odd number that is less than 3. Finally, randomly selecting a person under 21 years old or randomly selecting a person over 30 years old. These are mutually exclusive events because a person cannot be under 21 and over 30. Addition rule number 1 says when two events, A and B, are mutually exclusive, the probability that A or B will occur is the probability of A or B is equal to the probability of A plus the probability of B. For example, in the United States, there are 59 different species of mammals that are endangered, 75 species of birds, and 68 species of fish. If one species is selected at random, find the probability that it is either a mammal or a fish. There are a total of 202 species under consideration here, of which 59 are mammals and 68 are fish. The probability of choosing a mammal or fish at random is 59 over 202 plus 68 over 202, which is 127 over 202, which is about 0.609 or about 61%. The events are, of course, mutually exclusive. An animal cannot be both a fish and a mammal. The first addition rule for probability can be extended to 3 or more events. The probability of A or B or C or so on is equal to the probability of A plus the probability of B plus the probability of C plus lots of other stuff, however many we want to add. Addition rule 2 says, if A and B are not mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. For example, a single card is drawn at random from a standard deck. Find the probability that it's either a 9 or a diamond. In a standard deck, there are 52 cards, of which 4 are 9s, 13 are diamonds, and the 9 of diamonds is both. So the probability of drawing a 9 or a diamond is the probability of drawing a 9 plus the probability of drawing a diamond minus the probability of drawing the 9 of diamonds. So that's 4 over 52 plus 13 over 52 minus 1 over 52. That comes out to 16 over 52, which is equal to 4/13, which is approximately 0.308 or approximately 31%. It gets more complicated when we add more events. For 3 statements that are not mutually exclusive, the formula is the probability of A or B or C is the probability of A plus the probability of B plus the probability of C minus the probability of A and B minus the probability of A and C minus the probability of B and C plus the probability of A and B and C. That's, when we were just using 2, that was 3 items. Adding this one, it becomes 7. Here is what we need for 4 And there are 15 of these. 15 of these pieces that we have to put together in order to figure out the probability of 4 non-mutually exclusive events.